Oh, in this assembly, we have a motor. The motor applies a torque of 600 Newton meter to gear at A. The rotation speed is 120 RPM. Shafts 1 and 2 are solid shafts, and the bearing shown allow free rotation of the shafts. Determine the torque, rotation speed, and output power provided by the gear system at gear E. Number of teeth have been given. This is actually a very straightforward calculation. The same as the previous examples, we start from the output, from the engine output. Then we just go through this system one step by one step. Okay, the output is at gear A. So we will go from A to B, B to C, to D, and then to E. So the first step, naturally, is that we need to figure out the engine output, the TA and omega A. Right. So here our TA is just 600 Newton meter. Okay, and omega A is 120 RPM. That is revolutions per minute. Right, this based on our conversions, the unit conversions. We get 120 times 2 pi over 60, and then we can convert it into radian per second. Right, so this will be 12.57 radian per second. Then let's look at what it's asked to do. We're asked to determine the torque, rotation speed, and output power. Okay, it's just TE, omega E, and PE. Okay, can we calculate PE now? Right, if you understand that P is a constant, so you can just use TA times omega A, that equals PE. Right, the P is a system level constant. Right, so let's look at the first TE. Okay, so to solve this, we just need to go from A to B to C to D and to E. Right. So first, let's look at A to B. A to B, we can define a gear ratio. Gear ratio AB is just NB over NA. That is 72 over 24. Gear ratio is 3. Right, so TB equals negative 3 TA. That will be negative 1,800 Newton meter. Right, then the second step, B to C. Since they are connected by shaft A, right, so we will get TC equals T1 equals TB. That is negative 1,800 Newton meter. Third step, from C to D, here we can define another gear ratio. I just gear ratio CD is just ND over NC. That is 60 over 30 or 2. Right, so TD equals what? Equals negative 2 TC. This will be positive 3,600 Newton meter. Right, then from D to E, they're connected by shaft 2. Right, here just TE equals T2 equals TD. Right, that is 3,600 Newton meter. Okay, so you can see that from A to E, the torque is enlarged by 6 times, right? Then let's look at the second one, that is omega E, right? Like how to get a omega E. From the beginning, A to B, we have the gear ratio, so just omega B equals negative omega A over 3. Right, that is a negative 12.57 over 3, negative 4.19 radian per second. Second step, omega C equals omega B. That is negative 4.19 radian per second. Right, then C to D, right, omega D equals negative omega C over 2, the gear ratio. It will be positive 2.1 radian per second. Right, then D to E, omega E equals omega D, 2.1 radian per second. Okay, so you can see that we just repeated the process from A to E to analyze the omega, from omega A to omega E. Right, but if you have understood the rule number 1, saying that P keeps constant, so if the T has enlarged by 6 times, the simpler method will be that it's just a simple solution will be that omega E equals omega A over 6. I get 12.57 over 6, 2.1 directly. Right, this is the simpler solution. In the end, PE just TE times omega E, or TA times omega A, or any couple, right? You can get the same result. Right, that will be this will be 3,600 times 2.1. Right, so we'll get 7540 watts.